So I whipped up this module pretty quickly, so it's a little rough, but I thought I'd just say a few things about input-output, just to help out the beginners a little bit, perhaps. Not much code here, but first I just wanted to mention the debug output function. Here's one of them. Debug out, it's called debug printf, this guy here. It's in exec library, so it's iexec. This, anything you send through debug printf basically will go to either the default serial port for the hardware, a debug buffer, and or console window via something called sashimi. Now, is everybody familiar with sashimi? Not fish.
I don't know what it is.
No? Okay. Well, it basically takes your serial output and pops it up in the window. There you go. That's the basic gist of it. Very popular, especially from 3.x days, maybe 2.x, I don't remember. It's been a while. It's the source code and everything's on OS4 Depot for that, I think. It's an open source thing. Very, very handy because in this kind of situation where maybe you have a Grim Reaper crash or something, you can't seem to get any output from it, you can use Sashimi to grab that output and save it to a file, or sometimes when the debug buffer doesn't work for you, you can use it. Anyway, I usually use the serial port raw to another computer where I capture the output. And usually what it is Max 1000 usually captures all the serial output. It's a very expensive serial terminal.
Yeah. Only the best for you.
Only the best serial terminals. I'm always compiling on this guy.
Really?
Yes. Because I'm always testing on that guy. You don't want to test on the same machine you're developing. So. Well, I don't. Console input and output. So many options again for input and output. Oh, it's just a little bit of a mess. But basically, every time you open a process, a DOS process, you get 3 streams created for you. You get the input stream, output stream, and error output stream. You get all 3 of these. They're free, just for you. And they can stream data to wherever you want, really. Sometimes it's a file, sometimes it's console, sometimes it's a handler. It can run around the system. I said here, usually output and error output share the same stream. Not always true, not a requirement. And I wanted to mention that by sheer coincidence, ISO-C has 3 streams as well, called standard in, standard out, standard error. Okay, 1, 2, 3, 1, 2, 3. Somebody copied somebody. Very important to know. So these 3 streams are created by automatically created by the C startup code for you. And they automatically bind to the input, output, error output of your process. So this is happening under the covers. So what I'm trying to explain there, if you use printf or IDOS printf, they will both ultimately end up going to a DOS output stream, one of these. Well, output or error output, depending on how you configure things. You can see this is a lowercase p, so this is ISO-C function, and this is Amiga specific. I put a little bit of warning here. It's not a good idea to mix and match these functions any which way you feel like, although I see a lot of people do. You know, some people go printf and then they go DOS printf and then they just flip around. The problem here is they are both buffered calls. And the buffers may or may not behave the way you think they'll behave. So I've run into situations where your buffer isn't flushed and you get kind of an intermixing of text. depending on what C library you're using, depending on the platform as well. Not just Amiga has this problem. So don't assume, should not assume one or the other, and should instead be consistent. Don't mess with buffered input and output streams, because they tend to bite you. I find it happens, especially when you're doing a lot of input-output, like say through SSH, for example, which is something I worked on. If you don't flush the stream the right way, you're going to get some mixing up and things won't work. You're debugging a very long time. So just thought I'd mention it. Be consistent and you'll save yourself a headache. And that's just console input-output. Streams, as they're called.
Yes.
File input-output. You know what a file is? On a disk file anyway, not a Unix file. But, most basic level I've just explained is you get read and write. So you can read data, write data. There's also open and close, but they're pretty boring. So read and write. Then you have your buffered data movers. Oh, and these guys are used for large chunks of data. Then you got the buffered ones, fread, fwrite. They buffer a little bit and then move things in chunks. So it's efficiency thing. With ISO-C, you have fread, fwrite. And these things are also buffered, but again, you can't make any assumptions about how they are buffered. So it could be buffered by the C library, or the C library may just drop it down into fread, fwrite. You don't know. You shouldn't know. So it's not a good idea to assume anything. If your code's dependent on that kind of behavior, you're going to be in trouble. Unix, it's another, remember Unix, it's coming back again. Unix has another set of input-output functions based, and they're called read and write. Very simple. The behavior of these ones are defined by POSIX. They are not ISO-C functions. I know a lot of people think somehow that they have something to do with ISO-C. They do not. They have nothing to do with ISO-C. So I see a lot of code mixing read and write, fread, fwrite, flipping, flopping all over the place. Runs okay on Unix, not so much on other platforms. Again, ultimately, all these functions have to end up calling fread, fwrite, or read and write, no matter which ones you're picking to use for your application. I think, Paul, you were working on LPD or something? Is that what it's called? A daemon? Internet daemon?
Yeah. And that's, I tried all those different things.
Yeah, I imagine you're desperate, right? And you're like, oh, let's try this one. Oh, let's try this one. Oh, how about this one? Oh, this one.
Finding different samples of code.
Yeah.
One sample of code will use one, another one will use another one. The same thing actually with the different streams. Some of them refer to them by different names. Some refer to console, some refer to STDIO or input or IO, whatever.
So you've already ran into
Lots
this
of
confusion.
inconsistencies.
Yes, yes. You're hitting it dead on, right? That's a Unix program. So yeah, we're trying to shoehorn it into Amiga, and things happen. What I'm telling you here is don't mix them, don't try to not understand what's going on. You're going to hurt yourself. Now in your case, underneath it's bound to a socket, which makes it even worse.
Right.
So you don't know that because
Yeah, I know. Well,
yeah.
I have to
Okay.
go it open, so I'm going to mess with it.
yes, because I remember reporting that way back when. Yeah, what I'm trying to say here is essentially all these are independent APIs. However, to make it more interesting, they let you convert from one to the other API, just to make things interesting. So you have this file no function. You pass it one of these pointers to a pointer to one of these streams, and it spits back a Unix file handle. You're like, what? How did that happen? Well, it's a Unix thing. It's for Unix. But we emulate it on Amiga because Unix is so popular. Actually, I don't know many OSs that don't have those POSIX functions on them. Not many. My embedded ones don't, but many do. And then we added another one just for fun. Get default file. It's kind of a funny name, but In CLib2, you can actually get a B pointer to the underlying file which is being used by these guys, which is a real big no-no as far as the encapsulation goes. Right? You're not supposed to know what's going on under the covers. But it can be highly useful for porting things from other OSs. So there's debate whether it's a good idea to let programmers use functions like this that let you break the barrier between the different APIs. You can argue, but you know, when you gotta get the job done, you gotta get the job done. So. And I mentioned that it's not a good idea to mix these APIs unless you're very careful. You gotta be very careful. I've learned the hard way about this kind of thing. The worst part isn't the AmigaOS's implementation of them, but if you try to make software that'll run on more than one OS, these will burn you bad. These will burn you bad. So, you know, mixing them up like this using FileNo and such, it'll hurt. And it'll be very subtle. It's the worst part. Very subtle problems. You'll lose data. What? So that's my basic input-output stuff I wanted to just get across. Any questions from the audience? That guy in the back, one of you guys? You fight it out.
Do you have an implementation of F-flush to allow flushing of the strings?
Does CLib2 have an F-flush? Yes. Yeah, absolutely. Yeah. I've used it. Yeah. CLib2 is a pretty complicated library because it's supporting all the APIs at the same time, and plus it mixes in sockets as well and pipes. Yeah, you probably, I don't know if you looked at the code, but it can get pretty hairy. It can get pretty hairy there. It works though. Question?
Yeah, so other than the fact that I'm familiar with F-read and F-write and the stuff from the C99 standard itself, is there any particular reason why I would choose to use those rather than the functions that are provided by the IDOS structure?
Any reason why you would use those?
Yeah,
Portability is the major reason.
Let's assume
Yeah.
let's assume for the sake of argument portability I'm not interested in. Okay? So if that was the case, I'm familiar with the standard I/O functions that you use on any system that has a C runtime. Okay, but should I continue to use those because I'm familiar with them, or should I go ahead and focus on using the AmigaOS native I/O?
Well, I've done the approach of using the standard I/O functions before, and eventually you're going to need a B pointer, I find, if you're going to be using other facilities in the OS. But it depends how big your application is going to get. If you're just doing a simple, say, shell-based pipe tool, you're going to read in stuff, manipulate output, doesn't matter. But if you're going to get into an application which is going to start interacting with Workbench, you're going to start, interacting with other pieces of the OS, you're going to need a proper DOS lock, you're going to need a B pointer at some point, and you're just going to hurt yourself trying to stick to the ISO C one. So the only commonality between the two really is file name, path, right? That's how you convert between the two. So that's what I've used as a workaround. Like I'm manipulating here with standard I/O. Oh no, I need a B pointer over there. Well, I got to open the file, so I take the file name, paste it over here, open it under DOS, do my thing, come back, use it normally. So it really depends on what your application is going to do.
Well, it's doing audio processing things basically, which is bringing in a byte stream. It's doing permutations on chunks of it, and then it's sending it various other places.
Well, audio processing, it wouldn't matter.
No,
You're not touching DOS, really.
No, I'm not.
Yeah.
But for debug facilities or whatever
Yeah.
else.
You're
basically,
fine.
All I'm looking for is there really a difference between these things, or is it, at the end of the day, does it go and call the stuff in DOS.library?
End of the day, it's always calling DOS.
Okay.
Yeah.
Okay.
So It's just another layer. It's a very thin layer
In
too.
other words, it doesn't matter, but just keep it consistent for Samsung calls.
Yeah, yeah,
Okay.
yeah. Yeah, just consistency. You know, if you don't need the DOS facilities and, you know, maybe you don't want to torture yourself with them. They're a little weird sometimes.
I'm writing an awful lot of debug files. So.
Log files are very good.
Lots and lots and
Log
lots.
files are good, yeah, log files are good. Yes?
Suggestion is to always use Unix, the portable Unix.
The suggestion is to
Or
always...
your suggestion is, instead of using the Amiga specific, is to pretty much always use the portable.
Well, it depends what you want your code to do. If you want just to run on Amiga systems, use the DOS one.
Well,
But if you're ever going to go to any other system,
yeah, but you may not know this year or next year whether you're going to port it, or if somebody else wants to port it,
and,
so.
and it's not that bad switching APIs when you're going from Amiga out, because Amiga API is rather simple. It's simpler than it's much simpler than
Then going
Unix.
the other direction.
Yeah, going from Unix back to Amiga,
Right,
Amiga
right.
DOS is tougher, I found.
But the,
So you got the I/O control fund and
the other critical piece is what's inside the brackets, right? And I think that the IDOS F-read is very similar to the regular F-read in terms of what it takes.
oh yeah, they all take a file handle and a size, length, a buffer.
So
They look identical.
Yeah.
You could even macro them in most cases, and you wouldn't know, right? Or you can get fancy and do a wrapper.
Yeah,
most of the time.
so to your point, that if you write it using one, you can just change what the call is without having to go inside the code and change what it's actually calling or doing, because most of that should be very similar on porting.
Lost me.
So,
Say that one more time.
so if you're using IDOS F-read,
Right.
the parameters that it takes are the same parameters as F-read.
Yes.
So the fact is that if you use one and you find you need to change the other, you can do a global search replace for,
Right.
for this one.
Right,
It's not true
right.
for everything.
Yeah.
So some things you
For
can get away
simple
with.
I/O, it's yeah, you can get away with it.
Can you talk about the use of capitalization and what it means in the name of the function? Because these functions are case sensitive.
Yeah,
It's
C is
very
case
important.
sensitive. Yeah. Well, and Amiga likes to use capital letters for every word. So that's how you kind of get a good hint it's an Amiga function. Yeah, I probably should have mentioned that earlier. ISO-C is, all functions are lowercase, if I remember. All constants are uppercase.
I think, yeah.
Yeah. I don't know if that's 100% true, but it's darn close. I haven't read the standard lately. And then, of course, POSIX. Is that all lowercase?
No. There's a few.
I think there's a couple mixed case in
There's
POSIX.
a few cases.
Yeah, there's a couple mixed in there.
It's just a wasted keystroke.
So usually you can tell it's a Amiga function by, well, if you're using interfaces, of course, it's obvious. But if you're not, then it's the case of the letters. Any other questions? I knew this would be simple. I just wanted to mention a couple gotchas.
Will there be discussion at some point on how to interact with the file system handlers?
There could be. How to interact with handlers?
Yeah.
Or how to write a handler?
Yeah.
I could help you. Yeah, yeah. I don't know if the rest of the class can handle it, but yeah. Yeah, it's an interesting area of the Amiga. Very powerful. Very powerful.
I also understand that the underlying
Handlers.
file system handler mechanism is changing as well. Is that true?
Well, it's expanded. Handlers, there's more packet types.
Okay.
Yeah, and some things are simpler now in the handlers. A lot of simplification. Yeah, used to be a lot worse. Yeah, Yeah, but there's been a lot of work in that area to try and fix things up and to make handlers easier to write. And what Daus does is if it gets a packet that is new and your handler can't handle it, it'll automatically downgrade and use the old packet interface for you. It'll hide it. That's how you add new ones that replace the old ones. It'll emulate it. So you don't notice, but it's an extra code going on. It's quite well done.
Yeah.
It's Colin's work. Colin Huntsy. Yeah, he's very, very brilliant. Any other questions? Probably no one understands what a handler is. It's okay. All right, I'm done.